Advanced Algebra, Chapter 1, Lesson 6. In this video, we will look at theoretical probability. Experimental probability we looked at, and that's when you actually do the experiment and then you just add up the numbers and figure out your probability based upon those numbers. In theoretical probability, we're looking at what should happen or what could happen based upon the number of outcomes that could happen and the different ways that we could get the one we wanted to look at. And I know that sounds kind of confusing, so let's just look at it and see if we can't clear that up. Okay, so when you roll a number cube, you could get either the number 1, the number 2, 3, 4, 5, or 6. So how many different numbers are there? 6, right? Now, this set of all possible outcomes is what we call the sample space. Okay, sample space is all possible outcomes that you can get. All right, so there's, when you are rolling a number cube, there's 6 different numbers that you could get. So that's your sample space. When you're tossing a coin, you can get either heads or tails. So you have 2 options. So your sample space is 2. When you're shooting a free throw, you can make or miss. Sample space is 2. Now when you're rolling 2 die, what's your sample space? How many different numbers could you get? Well, you could get either 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So your sample space goes up to 12. So the sample space is all the possible outcomes that could happen when you're doing a particular event. Okay, so that's your sample space, is all possible outcomes. Now when we're talking about possibilities or probabilities, we are still looking at a ratio. Whoops, I didn't want to cross that out. We're still looking at a ratio of outcomes. So we still have a numerator and a denominator because that's what a ratio is. Now our sample space, our possible outcomes, is going to be our denominator. Okay, the sample space is going to be the denominator. The numerator then is going to be the different ways that you could get a particular event that you want to look at. So for instance, well, let's look at some notation and then we'll take a look at a couple of examples. So here's our notation, and it looks very similar to experimental probability. We have the probability of A, and A here represents the outcome that we're looking at. So for instance, if we were looking at rolling a die, let's see if we wanted to look at what's the probability of getting a 2. So the probability of a 2 would be in here. If we're flipping a coin, the probability of getting a heads would be in here. Okay, so our sample space, how many possible outcomes there are, is our numerator. And then our denominator. Our numerator is then how many ways could we get the outcome that we're looking at? How many different ways are there to get or to have that particular outcome happen? Now, we do have to make an assumption here, and that is that the probability of getting any one of the events we're looking at, any of these outcomes, is the same. In other words, we're not working with a loaded die or a stacked deck or anything like that, that I'm just as likely to get a 2 when I roll the number cube as I would be to get a 6. Okay, so we are making that assumption. Okay, so it's a ratio, so let's go ahead and take a look at this one. So find the theoretical probability, so we're not looking at an experiment, nobody did this yet, of getting an even number when you roll a number cube. Okay, so our notation would look like this. In here, we're looking at getting an even number, so that goes in the parentheses. Now, we know it's a ratio. Now, our denominator is the possible outcomes that I could get. So when I roll the number cube, how many different numbers are there that I could get? I could get a 1, a 2, a 3, a 4, a 5, a 6. So there are 6 different numbers that I could get. All right, that's our sample space. Now, our numerator is even numbers. Okay, so what I want to think about here is how of these 6 numbers that I could get, how many of them are even? Well, 2 is even, that's 1. 4 is even, that's 2, and 6 is even, that's 3. So out of the 6 numbers in my sample space, 3 of them are going to make this event happen. It's going to give me an even number. So then I would reduce that, so my answer is, or the probability, theoretically speaking, is 1 out of 2, or 1/2, which means half the time that I roll this number cube, I should get an even number. Now, does that mean that half the time I will get an even number? No, this is just theoretically speaking. These events when I roll the number cube are not related. So if I roll a 3 on my first roll, okay, does that mean I'm going to get an even number on my next roll? Because 1 out of 2 times I should get an even number. Now, Theoretically speaking, yes, because 1 out of 2 rolls I should get an even number. But experimentally speaking, maybe not. I might roll a 3 twice, 2 odd numbers. So you see the difference between experimental and probability. And if you remember the problem we looked at before in the experimental, when you're tossing heads and tails or tossing a coin, what's the theoretical probability of getting a heads? Well, there's only 2 outcomes. That's my denominator. And heads I can only get one way, that's 1. So 1 out of 2 times, or half the time, I should get a heads. And half the time I should get a tail. Well, if you remember from our numbers that we got, that classroom experiment that they did, I think heads was like 43% of the time, or 47% of the time. So they didn't get it exactly 50-50. It was close, but not quite. So probability, theoretically speaking, just explains what should happen, theoretically, based upon the numbers, but it's not actually what might happen when I do the experiment. Okay, so let's do just 1 or 2 examples, because I think you probably got this down pretty easily. The probability then of getting a number greater than 5. Well, again, we're rolling a number cube, so there's 6 different numbers. How many of those numbers are greater than 5? Well, just one of them is greater than 5, the number 6. So the probability of getting that is 1 out of 6 times. Okay, let's do one more. What's the probability of getting an 8? Well, again, my sample space is a 6. How many 8s are there? None. So 0 over 6 is 0. So remember, what does 0 mean? The event is what? Impossible to happen, and it is impossible to get an 8 if you're rolling a number cube that only has the numbers 1 through 6 on it. Okay, now what's the probability of me getting a number that's less than 8? Again, 6 possible numbers. How many are less than 8? Well, all of them are less than 8. So that's 6 over 6 is 1. And again, what does the number 1 mean when we're talking about probability? That means it's absolutely certain, 100% going to happen. And that is true. When you roll a number cube that has the numbers 1, 2, 3, 4, 5, 6 on it, you are definitely going to get a number that's less than 8. Okay? So that's theoretical probability.